Hey guys, today we're going to be talking about the cerebral cortex and the divisions of it and function and where they're at. So let's hop right into it. We'll start by drawing a rudimentary schematic of the brain. If we're looking at it from superior view, we've got two hemispheres here, and we're going to have 5 lobes. So let's list them over here. So lobes of the cerebral cortex. The lobes of the cerebral cortex. We're going to have a frontal lobe, which takes up, from this view, it takes up a lot of the real estate here of your brain. We have 2 of these each, right? Because you have the left and the right hemisphere. So left frontal lobe and right frontal lobe. So frontal, F. Then we're going to have a parietal. Well, let's see. First we'll draw on our temporal lobe here. Temporal lobe is going to look something like this from this view. It probably actually doesn't come up that high since we're looking at it from the top, just to give it some space there so you can associate it with. So these are going to be our parietal lobes. I'm sorry, these are temporal. Let's just back up here. Then we're going to have our parietal lobes, which are right here. Parietal. Lobes. And occipital lobes in the back. Occipital lobes. That's only 4, right? And I mentioned there was 5. So you're going to have a 5th lobe called the insula that's actually found deep to the frontal, parietal, and temporal lobes. And for the purpose of this webcast here, I'm going to draw it right in here. I'm not 100% sure where it is. I just know that it's taken up by, it's overlapped by parts of the parietal lobe, the frontal lobe, and the temporal lobe. So we're going to land somewhere in here. The main thing to know is that it's deep. You're going to find it between or underneath these lobes. The insula. There's no H on that. Okay. These are followed by lobes. Frontal lobe, temporal lobe, parietal lobe, occipital lobe, and it's just called the insula, or the insular cortex. So let's just run through some quick functions. So we'll start with, let's see, functions of each lobe. Frontal. Frontal lobe is where you're going to have, where most people associate with like their consciousness, where they have conscious thought, conscious motor activity. So there you're going to find your primary motor cortex, which is conscious control of voluntary movement. So put voluntary movement here. We're going to have our premotor cortex, And there we're going to have, it's going to coordinate movement with sensory information. Coordinate movement with sensory information. Coordinate movement with sensory information. And our prefrontal cortex. Prefrontal cortex. And there we're going to find personality, cognition, planning, and conscious thought. Personality. Wow. Personality, cognition, thought. We'll leave it at that. And spatially, these are going to be, let's see, here we're going to have our primary motor cortex, primary motor, and here's the premotor, and then here's the prefrontal. So it's going to move anteriorly as this list goes down. We'll switch colors here and talk about the parietal lobe. Parietal. Here we're going to find our somatosensory cortex. Somatosensory cortex. And what this is going to do is integrate sensory info. And so there's a figure called the sensory homunculus, which I think you've probably already gone over in class. And it's found on page 398, figure 1319 of your book. And what that sensory homunculus shows is the spatial representation of where your brain interprets or receives signals from the different portions of your body. And it shows that places with the most acute sensory awareness are going to take up the most area. So we get, so integrates, so we'll say integrates sensory info. There's a somatosensory cortex that receives and interprets somatic senses, so touch, taste, somatic senses. Let's see, moving down the list, so skip temporal, so we'll go to temporal. Temporal lobe, excuse me, is going to have both the auditory cortex and the olfactory cortex. So it has auditory cortex, which is going to receive and interpret auditory stimuli. So hearing. And olfactory cortex. Olfactory cortex, which is going to do this as well, but also this olfactory cortex is reduced in humans. It's reduced in size in humans in comparison to comparative anatomy, which allows for the limbic system to take rise. And in this area, so reduced in size in humans. Let me finish this thought. And then that space is dedicated to the limbic system. Dedicated to limbic system. And this is involved in emotion and emotional memory. Involved in emotion and emotional memory. Final two lobes, we'll see the occipital lobe. You can probably guess what its main job is. Occipital lobe. And this contains a primary visual cortex. Primary visual cortex, which receives and interprets info from the eyes. Receives and interprets info from the eyes. And all these cortices that I've mentioned, the primary visual cortex, somatosensory cortex, primary motor cortex, these are all contralateral. Let's put this in. Contralateral, which means that the regions on the right side are associated with the senses or the actions on the left side. Forgot to mention that earlier. There's also a visual association area. Visual association area. Association area, which is further responsible for interpreting visual information. Further responsible for processing visual information. Finally, we have the insula, or the insular cortex. This is going to have your gustatory cortex, which is taste. Visceral senses. Visceral senses from your gut. And balance. This integrates sensory information and has a role in emotion. So we'll cut it off there, and we'll pick up later on this week with another webcast. Thanks for listening.